What if I told you that right now, as you watch this video, an object from another star system is hurtling toward our Sun at 31 at 13 miles per second? This isn't science fiction. This is happening. Here's the impossible number. Comet 3I Atlas has traveled for potentially millions of years across interstellar space just to reach us. And we only discovered it a few weeks ago. It's only the third confirmed interstellar visitor in human history. And astronomers around the world are scrambling because this one is different from anything we've seen before. We have a messenger from another solar system, and it's about to give us secrets we've waited our entire existence to learn. Stay with me here, because by the end of this video, you'll understand why 3I Atlas might be the most important astronomical discovery of the decade. Let me put into perspective why astronomers are losing their minds over this. The first interstellar object we detected, 1I Oumuamua, in 2017, was tiny, maybe 100 to 1,000 meters long. We barely saw it, and it was already leaving when we spotted it. The second, 2I Borisov in 2019, was a more traditional comet, about 1 kilometer across. 3I Atlas? Current estimates suggest it could be significantly larger, and we caught it inbound. For the first time in history, we've spotted an interstellar object while it's still approaching the Sun. You might be thinking, okay, so it's bigger, and we found it early. What's the big deal? Here's the big deal. Every telescope that can reach it is being pointed at 3I Atlas right now. We're gathering data on its composition, the actual materials from another star system. Materials that formed around an alien sun billions of years ago. For the first time, we can study interstellar chemistry in detail while the object is active and outgassing. The Hubble Space Telescope, the James Webb Space Telescope, ground observatories across 6 continents. Everyone wants a piece of this, and what they're already finding is raising questions nobody expected. Where did this object actually come from? What star system birthed it? And why is it behaving the way it is? The answers might reshape our understanding of how solar systems form, including our own. Before we can understand why 3I Atlas matters, you need to grasp what interstellar objects actually are and why they're so impossibly rare. Our solar system is surrounded by the Oort cloud, a theoretical shell of trillions of icy objects extending halfway to the nearest star. These are the leftovers of solar system formation, gravitationally bound to our Sun. Occasionally, gravitational disturbances kick an Oort cloud object inward, and we see it as a long-period comet. Comets like Hale-Bopp or Neowise come from our own cosmic backyard. But here's the thing. Every star system probably has its own Oort cloud equivalent. And over billions of years, gravitational interactions eject objects into interstellar space, sending them wandering between stars. Scientists have estimated that at any given moment, there could be thousands of interstellar objects passing through our solar system. The problem? They're small, dark, fast, and we had no way to find them. Until recently. Modern survey telescopes like ATLAS, Asteroid Terrestrial Impact Last Alert System, Pan-STARRS, and the upcoming Vera Rubin Observatory scan the entire visible sky repeatedly, detecting anything that moves against the background stars. This is where things get strange. When astronomers track a new object's orbit, they calculate something called eccentricity. Objects bound to the Sun have eccentricities less than 1, elliptical orbits that bring them back eventually. An eccentricity greater than 1 means a hyperbolic trajectory. The object isn't bound to our Sun. It came from outside, and it's leaving forever. Oumuamua had an eccentricity of 1.2. 2I Borisov had an eccentricity of 3.36. 3I Atlas? Its orbit confirms it's unquestionably interstellar. It will swing around the Sun and never return. But detecting an interstellar object is one thing. Understanding where it came from, what it's made of, and why it looks the way it does, that requires catching it early. And for the first time, we have. The clock is now ticking. 3I Atlas will make its closest approach to the Sun. Give us a few months of prime observation, and then vanish into interstellar space forever. Whatever we learn, we need to learn now. And what astronomers are already discovering is creating intense debate. What I'm about to reveal is the actual science unfolding in real time, the discovery story, what telescopes are finding, and why some astronomers think 3I Atlas could tell us things about alien solar systems that we've never known. If you're fascinated by humanity encountering objects from beyond our solar system, hit subscribe right now. I cover breaking space discoveries every week, and this story is evolving as we speak. Let's continue. The story of 3I Atlas begins with the discovery moment, and it almost didn't happen. In early 2025, the Atlas Survey System, a NASA-funded network of telescopes in Hawaii, Chile, and South Africa, designed primarily to detect dangerous asteroids, flagged an unusual object. The initial detection showed something faint, moving against the background stars. Standard procedure is to calculate an orbit from multiple observations. When astronomers ran the numbers, they noticed something strange. The orbit didn't close. It was hyperbolic, coming from outside our solar system. But this had happened before, with Oumuamua and Borisov. What made 3I Atlas different was the timing. The object was inbound, still months away from its closest solar approach. For the first time ever, we had advance warning. The astronomical community mobilized with unprecedented speed. Dr. Larry Deneau and the Atlas team at the University of Hawaii confirmed the interstellar nature within days. The Minor Planet Center issued an official designation. Then the big guns came online. Hubble Space Telescope Target of Opportunity observations were approved. James Webb Space Telescope time was allocated. Ground-based observatories began spectroscopic campaigns. And immediately, the data started telling a surprising story. 3I Atlas was developing a coma, the fuzzy envelope of gas and dust that surrounds an active comet. This meant it was outgassing, releasing materials as solar heating began to affect it. This was different from Oumuamua, which showed no obvious coma and sparked wild debates about whether it was even a natural object. Remember the alien spacecraft speculation? That happened partly because Oumuamua didn't behave like a normal comet. 3I Atlas was clearly cometary, clearly releasing material, clearly giving us samples of interstellar chemistry to analyze. But the spectroscopic data raised new questions. Initial readings showed familiar signatures, water ice, carbon compounds, similar to comets from our own solar system. But ratios of certain isotopes appeared different from anything in our cosmic neighborhood. If confirmed, this would be direct chemical evidence of another star system's composition. Astronomers pushed for more observations. Every telescope that could reach 3I Atlas was mobilized. And then the trajectory refinements came in. With more observations, astronomers could trace the object's path backward through space and time, attempting to identify its home star system. The results? Complicated. We'll get to that. But first, you need to understand what 3I Atlas is actually telling us about the universe. Here's what 3I Atlas is actually revealing, and why it matters for understanding solar systems everywhere. Discovery. 1. Interstellar comets are real and detectable. This sounds obvious, but it's profound. For decades, astronomers theorized that interstellar objects should pass through our solar system regularly. Oumuamua confirmed they exist. Borisov confirmed comets could survive interstellar journeys. 3I Atlas confirms we can now reliably detect them while inbound, with time for detailed study. Dr. Karen Meech at the University of Hawaii, one of the world's leading experts on interstellar objects, has stated, "We're entering an era where interstellar visitors will become regular targets of study, not once-in-a-decade oddities." Discovery. 2. Chemical signatures from another star system. When 3I Atlas outgasses, it releases molecules that formed in its original star system billions of years ago. Spectroscopy allows us to identify these molecules by analyzing the light they emit or absorb. Early results show volatile compounds, ices and gases that sublimate as the object approaches the Sun. The specific ratios of elements like carbon, nitrogen, and oxygen can tell us about the conditions in the protoplanetary disk where 3I Atlas formed. Here's the analogy. Imagine finding a bottle washed up on a beach with a letter inside. The letter might be in a language you can't fully read, but the paper, ink, and bottle itself tell you about the person who wrote it, where they lived, what materials they had access to, how they manufactured things. 3I Atlas is that bottle. The outgassing materials are the letter, and we're learning to read it in real time. Discovery. 3. Other solar systems make similar comets. One of the biggest questions in planetary science is whether our solar system is typical or unusual. Do other star systems have similar compositions, similar structures? 3I Atlas, despite coming from a completely different stellar environment, shows similarities to our own comets. This suggests that comet-forming processes might be universal, that the basic ingredients of solar systems are common across the galaxy. But here's where it gets complicated. Some measurements show differences, too. Certain isotope ratios don't quite match our solar system values. If these differences hold up under further analysis, they're fingerprints of a different stellar environment, a sun with different mass, different age, different chemical history. Dr. Darrell Seligman, an astrophysicist specializing in interstellar objects, has noted, "Every interstellar object is a data point about another solar system. With 3 confirmed detections, we're starting to build statistics, but we need dozens more to draw firm conclusions." Discovery 4. Backtracking the journey. By precisely measuring 3I Atlas's trajectory, astronomers can project backward, asking, where was this object 1,000,000 years ago? 10 million years ago? The calculations are incredibly sensitive to small measurement errors. But preliminary work is underway to identify candidate source stars. Here's the mind-bending part. Even if we identify the star 3I Atlas came from, that star has moved since the object was ejected. We're doing detective work across both space and time. The leading candidate stars are being evaluated based on their positions, velocities, and the likelihood of ejecting cometary objects billions of years ago. But the answer isn't simple, and that's where the controversy begins. Just when you thought we were getting clear answers, the complications emerge. Complication 1. We don't know exactly where it came from. Despite precise tracking, backtracking an interstellar object's journey is phenomenally difficult. Small errors in current velocity measurements compound over millions of years. Initial attempts to trace Oumuamua's origin yielded contradictory results. Different research teams proposed different source stars. Some candidates were later ruled out when better data emerged. 3I Atlas faces similar challenges. We might narrow down candidates, but we may never know its true home star with certainty. Complication. 2. Unexpected acceleration patterns. Oumuamua exhibited what's called non-gravitational acceleration. It was speeding up slightly as it left the solar system, beyond what the Sun's gravity alone could explain. This sparked intense debate. Outgassing can accelerate comets, but Oumuamua showed no visible outgassing. Theories ranged from hydrogen ice sublimation to, yes, alien technology. Astronomers are watching 3I Atlas carefully for similar anomalies. Any unexpected acceleration would require explanation and might revive debates about what these objects actually are. Complication. 3. What if it's not from a star? Here's a wild possibility some astronomers consider. What if some interstellar objects don't come from star systems at all? There may be free-floating planets between stars, ejected from their birth systems early in galactic history. These rogue worlds could have their own mini-Oort clouds, shedding comets into interstellar space. If 3I Atlas came from a rogue planet environment, rather than a normal star system, its chemistry would tell a completely different story, one about the dark spaces between stars. Complication. 4. This is just the beginning. The Vera Rubin Observatory, currently under construction in Chile, will begin operations soon. Its survey capabilities will exceed anything we currently have. Astronomers predict Rubin will detect dozens of interstellar objects over its operational lifetime. 3I Atlas might soon be just one of many. This sounds like good news, and it is. But it also means we're seeing these objects at a specific moment in technological history. Before 2017, we detected 0. Now we're at 3. Soon we might have 50. The questions we can't answer about 3I Atlas might be answerable with future detections, or they might get more complicated as we discover interstellar objects don't fit neat categories. The deeper mystery: what does this mean for life? There's a theory called panspermia, the idea that life's building blocks, or even life itself, could travel between star systems aboard comets and asteroids. If interstellar objects regularly pass through solar systems, carrying organic compounds from their origins, they could theoretically seed other worlds with the ingredients for life. 3I Atlas isn't proving or disproving panspermia, but it's showing that material does travel between star systems. The cosmic isolation we assumed might not be as absolute as we thought. We're not just studying a comet. We're studying the interconnectedness of the galaxy. Okay, this is where I want your input. Given everything we've covered about 3I Atlas, what aspect do you find most significant? Option A. The chemistry. Finally getting direct samples of another star system's materials. Option B. The trajectory, potentially identifying which star this came from. Option C. The implications, what this means for how connected the galaxy really is. I genuinely want to know what you think. Drop A, B, or C in the comments and tell me why that aspect grabs you most. I read every comment, and your perspectives often shape future videos. Let's discuss this interstellar visitor together. Here's why 3I Atlas matters beyond just astronomy. We've discovered thousands of exoplanets, worlds orbiting other stars, but we've never had physical samples of other solar systems. Every exoplanet we study is through indirect methods. Light curves, spectroscopy from billions of miles away. Interstellar objects are different. They're here. They're material we can almost reach out and touch. If we could send a spacecraft to intercept one, which missions are already being proposed, we could return actual samples from another stellar environment. The European Space Agency has studied concepts for comet interceptor missions that could be pre-positioned, waiting for the next interstellar visitor. NASA has evaluated similar rapid response architectures. 3E Atlas came too fast for any mission we could launch now, but the next interstellar object might be interceptable if we prepare in advance. For astrobiologists searching for life elsewhere, interstellar objects represent something profound, proof that material moves between star systems. If organic molecules can survive interstellar journeys, the chemistry of life might be more universal than we assumed. For planetary scientists, comparing interstellar comet chemistry to our own solar system comets provides calibration points. We can finally test whether our solar system's composition is typical or unusual. You now understand something most people never consider. We're not isolated. Our solar system is porous. Objects flow in and out across cosmic timescales, connecting us to the greater galaxy. That's not just scientifically interesting. It's philosophically profound. Here's the beautiful reality of this moment. We live in the first era of human history where we can detect messengers from other star systems. Our grandparents couldn't have spotted 3I Atlas. Our technology was simply too primitive. The Vera Rubin Observatory begins operations imminently. JWST is already studying 3I Atlas. Ground observatories worldwide are contributing data, and the discovery rate will only accelerate. More interstellar objects mean more data points, more chemistry, more trajectory histories. Eventually, a complete picture of how solar systems across the galaxy form and evolve. 3I Atlas is a postcard from the cosmos, and we're learning to read the message. The next postcards are already on their way, and our ability to understand them grows with each passing year. The story of interstellar visitors is just beginning, and we're here for the opening chapter. But 3I Atlas isn't the only mystery currently unfolding in our solar system. In upcoming videos, we're exploring the Oumuamua controversy, resolved. New research may finally explain that strange acceleration, and not everyone agrees on the answer. How we could actually intercept an interstellar object. The mission concepts being developed to sample the next cosmic visitor. The strangest objects in the outer solar system. Worlds that challenge our understanding of how the solar system formed. If any of those spark your curiosity, subscribe and hit the notification bell. This channel is your front row seat to cosmic discoveries. Thank you for joining me on this journey to understand a visitor from the stars. Right now, 3I Atlas is crossing our solar system, an ancient traveler carrying secrets from another sun. Astronomers are watching. Telescopes are recording.